Right, so determine the moment of inertia of the solid obtained when the area enclosed between the curve y squared is equal to 4x, the line x is equal to 4, and the x-axis. Okay, so now this rotates about first the x-axis and then the y-axis. Now, we need to go one step further here. Sometimes in the exam, they do ask you to go one step further. We need to express both answers in terms of the mass m. Okay. So now, let's sketch our graph. Y squared is equal to 4x. By now, when it takes a few seconds to sketch this graph, you realize you check the standard form. X is equal to ay squared. A is positive. Your graph is facing the right. If a was negative, it will be on the left. Okay. So here is your parabola. This is a full parabola. It's not just the upper part or not just the lower part. It's clear that it's y squared. Okay. So now, here is the graph. Y squared is equal to 4x. It turns here at the origin. What about the line x is equal to 4? That is a straight line. It's cutting the x-axis at 4. Okay. So now, we need to calculate the moment of inertia when this rotates about the x-axis. Okay, so let's write that down. So we know rotates about the x-axis. Now, we need to make a choice. Are we going to use dx or delta x, or are we going to use a delta y? Right. Most of you will obviously choose delta x, so let's use delta x here. Okay, so now we need to rotate this area about the x-axis. Remember, the x-axis is now like an axis of symmetry. It cuts this parabola into two equal halves. The upper area is equal to the lower area. But now, we're not working on area. We are going to work out the volume. So, if I take the upper area and rotate it, it will cover the lower area automatically. Okay, or if I take the lower area and I rotate it, it will cover the upper area. Okay, so what will your radius be now when we are rotating around the x-axis? Your radius will be in terms of y. Right, so now I chose delta x. So I know delta x is perpendicular to the reference axis. If it is perpendicular, we're going to use the formula mass times k squared. Also, when we're working out the volume, we will be using the disk method. If I chose delta y, we will be using the shell method. Okay. Okay, so now delta I x, that's with reference to the x-axis. That's what the question stated. So your formula is mass, which is going to be delta m times k squared. So now, what is mass? Mass is equal to density times the volume, and also K is equal to the radius all over root 2. So delta M is going to be P times delta Vx, because I'm rotating around the x-axis, times your K squared. Now let's go to K. We are rotating around the x-axis here. Can you see that? So the x-axis is now the center. The distance from the center to any point on the circumference, we are measuring up or down in terms of y. So your radius will be in terms of y here. So that will be y over root 2. So therefore this will be y over root 2. Volume, disk method. So your disk method, you know it's area of base times your perpendicular height. So it's going to be pi r squared, which is y squared, times your height, which is delta x. And this is going to be multiplied by y squared over 2. Okay. So you needed to remember, you have to remember the difference between the disk method and the shell method. Okay, this is the third time we're doing it. Third. I'm talking about the third exercise. First it was volume, then it was center of gravity. Now it is moment of inertia. So, your total. Take your constants, which is P times pi over 2. This is dx. We are integrating with respect to x. So that will be b and a. Y squared times y squared is y to the power 4. And there is your dx. Okay. So now, what is your b and a? Your B and A, where does the area begin? Where does it end? So it begins here at 0 and it ends at 4. You can see that the x values. We are only interested in the x values here. So that will be 4 and 0. And there's your dx. So we need to get y in terms of x. This is y to the power 4. What is y? What do we know? What is the equation that involves y here? So we have y squared is equal to 4x, but I need y to the power 4. So therefore, I will have to square the left hand side, square the right hand side. So therefore, let's y to the power 4, 4x all squared, that will be 16x squared. So I know that y to the power 4 is 16x squared. Okay, not too bad. So we can now integrate. What I'm going to do is I'm going to take out my constants. So that will be 16 pi over 2 p, that is 4, 0, that's my x squared. Right, the integration here is simple. For this specific example, 16 over 2, we get 8 pi p. Integrate x squared, that will be x to the power 3 over 3, and that will be 4 and 0. Substitute 4. 4 cubed means 4 times 4 times 4, which will be 64 over 3. Substitute 0. 0 cubed, that will just be 0. So now you multiply. Let's see what we get. 8 pi times 64, all divided by 3. What do we get there? Should get 512. 512 pi over 3. So that will be 512 pi over 3p. Right. So this is your answer in terms of p. So your answer in terms of the density P, what did the question state? Express both answers, this is the first one, in terms of the mass M. So what do we know? We know that mass is equal to the density times the volume. So therefore, if I divide both sides by the volume, M over V will equal to P. Okay, so now I can replace this. So this will equal to 512 pi over 3 times M over V. I'm replacing P here with M over V. Can you see that? Now, what is V? What is V? What does V stand for? Volume. Did we work out the volume? No, we didn't work out the volume. We used it to work out, to get our formula for the moment of inertia. We need to now work out the volume and then substitute for V. Let's say if I worked out the volume to be 32 pi, then I will divide, and then my answer will be in terms of the mass. Right, so how do we work out volume? Here is our volume. Delta Vx. What is delta Vx equal to? Pi y squared delta x. Can you see that? So now, let's work out our volume here. So your volume is equal to pi, that's your B and A. We are still using the x values. Y squared times dx. What's your B and A here? The same B and A values, which are 4 and 0. What is y squared? Go back to the equation. What is y squared? Simple, y squared is just 4x. So I'm going to take out the 4 pi there. I will just integrate x instead of integrating 4x. So I'll integrate x, that will be x squared over 2, substituting 4 and 0. So now let's see what happens. So that will be 4 pi over 2. Substitute 4 into x, 4 squared. That will be 16 minus 0 squared will be 0. So 4 pi over 2 times 16. 16 divided by 2 is 8 times 4 is 32. So the answer is 32 pi. So that is the volume, 32 pi. So what must I do now? I need to replace V with 32 pi. Can you see that? So therefore, Ix is equal to 512 pi over 3 times M over V. What was V? V was 32 pi. What do we get? Now we can use our calculator and round off to 3 decimal places. That is the instruction in the exam. All final answers has to be rounded off to 3 decimal places. You don't round off anywhere else except the final answer. What do we get? So we get 5,333 M. Your answer is in terms of M. Let's assume we are sticking to the same representative element, delta x, but now, which axis are we rotating about? We're rotating about the y-axis. Okay, so there I just took the top area, and if you rotate it around the x-axis, it covers the bottom part. Now, it's this entire area rotating around the y-axis there. Okay, the entire area. So it's the entire area. This whole area is now going to be rotated. So what's going to happen here? There is, if it's rotating there, this is what's going to happen. Alright, so you picture that in your mind. Okay. Picture this whole area being rotated around the y-axis. Now, let's assume I used delta x. So now, what do we know? Delta x will be parallel to the reference axis. If it is parallel to the reference axis, so therefore, I'm going to use the formula mass times the distance all squared. What else? For volume, I have to use the shell method. It's a bit of a more difficult interpretation when you're looking at the diagram to use the shell method compared to using the disk method. Okay. So now let's look at how we're going to interpret the diagram. So let's see. Alright, so let's start. Delta I y. The reference axis is the y-axis. Is equal to your mass, which is delta m, times the distance from the reference axis. From the y-axis, what are we measuring? From the y-axis, we will be measuring x, so that will be x squared. So we know that mass is equal to density times volume, which is delta Vy times your x squared. Okay, now the volume, shell method. So shell method is circumference times your height times your thickness. So what is the circumference? Circumference is equal to 2 pi r. We are rotating about or around the y-axis. So what is your radius measured in terms of? In terms of x. So we know our radius is measured in terms of x. Okay. What about the height? The height from here to here is the height of the representative elements. So the height is the difference between the top y value and the bottom y value. Okay. So if you interpret the graph this way, above the x-axis, okay, what is the equation of this parabola? The equation of the full parabola, we know that y squared is equal to, what is y squared equal to here? 4x. Okay, that is the full parabola. Now, what is the equation of the top curve? What is the equation of the bottom curve? Because we need to know what is the value at this point, subtract the value at the bottom. So now, you can see I drew the blue on the top, red in the bottom to show you the two different curves we're dealing with. So now, if I want to make y the subject of the formula, y is equal to plus or minus the square root of 4x, which is equal to, okay, let's just leave it as plus or minus the square root of 4x for now. This can be simplified further. Now, that means y is equal to the square root of 4x, or y is equal to minus the square root of 4x. On the upper side, above the x-axis, y1 is equal to the square root of 4x. On this side, y can only be negative, so y is equal to minus the square root of 4x. So, if I want to work out the height of the representative element, I will take the top graph, subtract the bottom graph. So, the height, in this case, my top graph is y1 and the bottom graph is y2. Right, so now, that's how we interpreted it. So now, delta Vy is equal to circumference, which is 2 pi r, your r is x, times your height. Your height is y1 minus y2, times the thickness there, which is delta x. Don't forget, we still have this x squared here. Can you see that? Times x squared. Okay, so now, alright, so now what I want you to do is write down the total, put in your integration sign. We are still dealing with dx here. Let's see if you can do the substitution here. Let me give you a few minutes for that then. Take out your constants. What are we integrating with respect to? We are integrating with respect to x, so we need to replace y1 and y2 in terms of x. Let's see if you can do that part. Because this is the most important part. To interpret the diagram, to get your formula right, the integration might be simple. You can see the integration was simple. Now let me give you a few minutes. Let's see if you can do it. Okay, so you had to now write down the formula for the total. So your constants there, let's see, what are the constants? It's going to be 2 pi p. We are still integrating with respect to x here. We did not change our representative element, you can see that. So we are still using b and a. So now let's see what we have there. We have x, okay, let's put y1 times y1 minus y2 first. y1 minus y2, what do we have here? X times x squared there, which will be x to the power 3, and that is dx. Right. So now, that is 2 pi p, b and a, it's the same b and a, we're not changing anything on the diagram. That will be 4 and 0. What is y1? y1 is the square root of 4x minus y2 is minus the square root of 4x. Okay. And this whole thing is multiplied by x cubed. So, negative times negative, that's a positive. So we got 1 square root of 4x plus another 1 square root of 4x, which will be 2 square root 4x. We're just adding like terms, so you can see that. Alright, so now we need to multiply first. We need to simplify, we need to know our exponents here. Okay, so here's the problem. We cannot multiply x by x cubed because there's a square root there. Can you see that? So what must we do now? We need to simplify this first. So we got the square root of 4x, which is actually the square root of 4 times the square root of x. The square root of 4 is 2, so that will be 2 root x. So the square root of 4x is 2 root x. So now let's rewrite it here. So the square root of 4x is 2 root x. Now I can multiply. You can see that. I can multiply this. So here 2 times 2, which will give me 4x to the power half times x cubed. I'm multiplying and the bases are the same. I add the exponents. Half plus 3 is 3.5, which is 7 over 2. Right, so now what I'm going to do is, I'm just going to multiply this 4 here. So 4 times 2, that will be 8 pi p. The integration turns out to be simple. The problem that you would have had is the simplification here. Okay, if you simplified it, this part is going to be simple. This is like N4 integration now. All you do is, you add 1. 7 over 2 plus 1 will be 9 over 2 divided by 9 over 2, which is the same as 2 over 9. That's 4, 0. Okay. So I'm just going to remove this here. 8 times 2, that will be 16 pi p over 9. I'm going to substitute into x to the power 9 over 2. Someone who's fast here, just do this for me on a calculator. 4 to the power 9 over 2. What do we get? 512, exactly 512. So that's going to be 512. You substitute 0, you get 0. Now multiply 512 times 16 pi over 9. We get 8192 pi over 9. Is that right? 8192 pi over 9 p. Don't forget the p there. So now this is going to be 8192 pi over 9. But remember, this is not our final answer. We need to express the answer in terms of the mass. So P is equal to the mass divided by the volume. We need to work out the volume. Let's work out the volume quickly. So where is the volume? Here is the volume, yeah? Delta Vy, this part here. Here is your volume. Can you see that? Right, so we just extract this information from our formula for moments of inertia. And some people are figuring out how to use a calculator, I can see that. Right, they're not getting this answer yet. Right, here's the volume. Circumference times height times thickness. Shell method. So that's going to be 2 pi. The same B and A, which is 4 and 0. What did we work out y1 minus y2 to be? y1, here's y1 minus y2. y1 minus y2. Here's it, y1 minus y2. So that will be 2 times the square root of 4x, which became 2 times 2, which is 4 root x. You understand that? We're not going to redo the whole process. We know y1 minus y2 was 4 root x, and we are multiplying it by x then. Okay. So now 2 pi times 4, that will be 8 pi. That is my 4 and 0. X to the power half times x, that will be half plus 1, 1 and a half, which is 3 over 2. Integrate x to the power 3 over 2. 3 over 2 plus 1 will be 5 over 2. Divide by 5 over 2 is the same as 2 over 5. We are substituting 4 and 0. Okay, I don't have space, so I want the final answer for this here. Substitute your 4 here, multiply by 8 pi and give it to me as a fraction. I know here we're going to get 64 over 5, am I right? 64 over 5. So we get 5, 1, 2, pi over 5. That is the volume, 512 pi over 5. Now, we take this information and we have to substitute it here now. Okay, so this is now equal to 8192 pi over 9 multiplied by m divided by the volume. The volume was 512 pi all divided by